Hello friends, how are you? Very good morning to all of you. Hope you are doing fine. Today we will try to understand the physical interpretation and try to visualize the four identities we studied till now in factorization. We would set some analogy corresponding to these identities. These identities can closely be understood with the concept of an area. So let us begin. So the first identity we studied in factorization was a plus b whole square, which was a square plus 2ab plus b square. So basically this identity can be understood with the concept of area. So we know, if suppose we have a particular square, so a square can be a two-dimensional figure whose both sides are equal. So suppose these are two sides of a square which are equal. Okay, so we'll try to understand this formula a plus b whole square, which is a square plus 2ab plus b square, and try to relate how this can be identified or visualized with the help of the area of a square and two-dimensional figure. So let us consider, suppose this is a square. Okay, so a square if has a side a, okay, whose length and breadth both are same, so its area, if suppose this is the closed area of a square, so area of a square is basically side into side. Okay, that we know. So a square. So likewise, if we'll try to understand the formula a plus b whole square, so that can be written as a plus b into a plus b. So if I'll consider a plus b as the one side of a square and a plus b another side of the square, and then try to understand what turn out to be. So let us take this example. Suppose we have a square whose one side supposes AB. Up to now this supposes A, okay, and this is supposes B. So up to this point, suppose this is having a side length A, and from here to here this length is B. Okay, this is one side of the square, and then let us take another side. This suppose also is A, okay, and other side is B, which is from here to here. Okay, and then we'll try to draw the same four sides with the help of these lines. We'll try to pretend that that is basically is a square. Okay, so that is the square, and then we'll divide. Okay, so that side is also B. Okay, just as this side is. Suppose this A, B, C, D is the vertices of this square, and we'll just draw this line this way. Okay, as I'm doing, and then another line from this point. Okay, so you can see that this line is of length A from here. If it is A, it should be A. Likewise, this length should be of A. Okay, so obviously area of a square is side into side, so that should give me A square or A into A. Okay, likewise this is having a length of B, because this length is equal to this and this is equal to B, so that is B into B, which is nothing but B square. This is a rectangle basically whose one side is A and this side is B, so its area should be A into B. Okay, likewise that should also be A into B. So the whole area of a square we know actually is side into side. Okay, here one side is this one, a plus b, another side is a plus b. So side into side is a plus b, and another side is a plus b, and this is equal to the smaller areas of all the sides. So we have basically four areas. One is this, other is this box, this, and then fourth one. So just I will add these four boxes. So this is having an area of a square, then this one, which is a into b, then another is this one, which is a into b, and then after is this one, which is b square. So just I'll add up. So that would be a square, 1ab and 1ab would be plus 2ab, and that would be b square. Okay, so that is the area, a plus b, a and a plus b, which is nothing but a plus b whole square. So just by considering the area of a square, we are able to find the formula for this algebraic equation. Okay, so in this way we can write that a plus b whole square would be a square plus 2ab plus b square. Okay, let us take another example. Suppose now I have the another equation, which is a generalized one, which is a square plus a plus b into x plus ab, and which was nothing but x plus a and x plus b. Okay, so that can be visualized as a rectangle whose one side is x plus a and other side is x plus b. Suppose this is x, okay, this side is x, and suppose this is a, okay, that suppose is a. Likewise this is x, okay, just this one, because this size and this side should be equal, so that suppose is x, but another side is x plus b, so that is x, and b suppose is this one, up to suppose this, up to this length is your b. Okay, so just make this, complete this rectangle. So I will have that kind of a figure. Now my task is to find the area. So area of this figure would be side into side, and this both sides is x, so area would be x into x, which is nothing but x square. Likewise this side would have an area of length into breadth. Here length is a and breadth is x, so a into x. Likewise here length is b and breadth is x, so that is b into x. Okay, that would be another area, and this would having the area of, this is the length of a, because that should be equal, and that should be b, because that should be equal. Okay, so this area should be a into b, side into side. Here one side is a, another side is b, so length into breadth would be the area. So total area, so the total area of this rectangle would be one side, which is x plus a, okay, and another side, this one, which is x plus b, okay, would be equal to the sum of all the individual segment of this area. So there are four segments. One is this, which is having an area of x square. Another segment is this one, which is having an area of ax. Then this one, which is bx, and then the last one, which is a into b. So just you have to take from the middle term x common, so only a plus b would remain. Okay, and then this one, which is ab. So in this way we can find out the area of this particular rectangle. Okay, so let us take another example. Let us take next identity, which is a newer one. Suppose a plus b plus c, okay, whole square. So here this can be written as a plus b plus c into a plus b plus c, right? Because that is having a power of 2. Okay, so now I should make a square whose length can be divided with a, b and c. So suppose that is up to this point, this is a, this is b, and that suppose is c. So likewise that is one length. Other side suppose this one, which is a, then this one suppose up to this point, that is b, and then this one, that is c. up to this point, that point suppose is C. Okay, so the whole length is A plus B plus C, likewise A plus B plus C, and then I will make segments. Okay, that suppose is a square, and then I will make small segments. You do it properly. So, okay, so this area should be A into A, so that would be A square, which is A into A. This area should be B and this one, so B into A, yeah, or AB you can write. This is C into this one, which is length here is C and breadth is A, so AC. That should be A, that is A, and that is B, so that is AB. That should be B, this is B, and this is, you can say B, so that is B square. This length is C and that is B, so that is BC. Here this is A and this is C, so that should be CA. Here this length is what? Length is here is B and breadth suppose is C, so that would be BC. And here it is C and that is also C, so that is C and that is C, so that is C square. So it means that if you multiply A plus B plus C with another term which is A plus B plus C, so that should give me the total sum of the area of this individual boxes or blocks. So this block has an area of A square, then this one which is AB, then this AC, then this block which is AB, then another block which is B square, then another block which is this, which is BC, then this one ACA, then BC, and then next one is the C square. So let us just rearrange that formula. So that should give me A square, just circle this one, and then this one which is B square, then this one which is C square, then AB is twice, one is this, another is this one, okay, that twice of AB, then this one BC, so BC is here and this is the BC, so twice of BC, and then CA, which is this one and this one, so that is CA, so CA is also twice. So that is the total formula for A plus B plus C whole square. So you can say that A plus B plus C whole square can be written as A square plus B square plus C square plus 2AB plus 2BC plus 2CA. Okay, so that is the formula. Very simple. So let us take another example. Just take this formula, A minus B and A minus B, which is A minus B whole square. That we know that the formula for this particular identity is A square minus 2AB and plus B square. How can you do it? With the help of an area. So let us take this one. So that is A minus B. Okay, so suppose I'll make a square whose side is A. Okay, that suppose is A, and then this one whose side again is A. Okay, that suppose is also A. Okay, and so that is the complete square whose side is A. Okay, very simple. Then suppose this up to this point, that is B. So suppose that is the B. This is basically B. So if it is B, so that should be what? A minus B. Okay, if I will subtract this B from whole this A, so that should remain A minus B. Likewise, if suppose this length is B, that should be equal. If this is B, so that should be B. So that length should be A minus B, because you have to subtract this B from the whole A. So A minus of this B would be this one, which is A minus B. Okay, very simple. So you can write A minus B, and then again you will do the math. So that should be B into B, so that is B square. Then this one, which is A minus B into this length, which is B, so B in one length and another length is A minus B. So length into breadth, length here is B and breadth is A minus B. Likewise this one, here length is B and breadth suppose is A minus B. Okay, fine. Okay, so what about this? That should be A minus B. This length is A minus B from here, and that is also A minus B. So the whole area of this particular segment should be A minus B. into a minus b, which is a minus b whole square, right? So that it means that the area, total area is the length of this square. The length of this square is a, and there is also a. So a into a, there is the total length. So a square should be equal to the sum of all these four segments. So first segment is having an area of b square. Another segment has an area of b into a minus b. Next, b into a minus b again, b into a minus b, and then the fourth one, which is a minus b whole square. But we are interested here to find this one. Okay, so let us rearrange that formula. So that should give me a square. Okay, that should give me b square. Then just multiply this one, so that would be ab minus b into b, that is b square. Then this one plus ab, and then b of b minus b square, and then this one, let it be as it is. So a minus b, because we have to find, that is our task to find. Don't expand that one. So let it be as it is. So just by looking it, you can see that this b is minus b and there is plus, so that would be cancelled out. And other terms you take here, so that would be a square on the left hand side. So that is a square. You take it here, this b square, so that would become b square. That it has gone to the left hand side. So that is on the right hand side, there is 2 twice of ab, and this one, which is a minus b whole square. Okay, so that can be written as again you can take here this term, so that would be a square. You will take here the 2ab would become minus 2 of ab, and this is the term remaining here, so that is b square, should give me this leftover term, which is a minus b whole square. Okay, so a minus b whole square now is a square minus 2ab plus b square. So likewise we can do it all the way. Okay, so that basically was the formula we have derived, and that was for all the formula up till now we have studied. So if suppose that power is not twice, but suppose it's thrice. So let us take an example where the power of a minus b or a plus b, so suppose it's thrice. It means that we now have to multiply a plus b 3 times, a plus b into a plus b and a plus b. But now we know that if 3 quantities are multiplied, that no more measures the area, that basically becomes a volume. Okay, so volume of anybody, suppose that that is a figure which is a square, we know it, but suppose I just elongate this length like this, so that become a rectangle. Okay, so this length suppose is a, this side is b. Suppose another side, suppose if this figure has a third side, which is like that. Okay, so that would make actually a 3-dimensional figure. So in that way, suppose that size is c. If you multiply this one, so that will measure the volume of this particular body. Okay, 3-dimensional figure. So that would measure the volume. So it means if the formula is having a cube here as a power, so it will measure the volume likewise. Okay, and then for higher terms, suppose a plus b power 4, something like that. So, but here physical interpretation is very difficult to find. Okay, very difficult to find. But here up to now, up to power 3, we can interpret particular formula with the help, whether it is twice or thrice. If its power is thrice, you can relate it with the volume. If it is twice, then it can be related with the area we already have done. So that's the final. Thank you for watching the video. I hope you are able to correlate the identities we studied till now. If you like the video, click on the like button and subscribe the channel. Also click on the bell icon to get my latest video notification, and share my video to benefit your friends and colleagues at large. So thank you very much for watching my video. Thank you.